not coming yet. I don't think.
That's okay. Go back to where you normally stay.
I don't want to be alone though.
That's okay.
What?
We're all alone in the end.
Don't say that.
Chloe, Luca, Felix is not.
He's right there.
Oh, Felix is late.
Sorry, Mr. Newcomb.
Nicholas, Taylor, Eric, Anae, Eshwan,
I'll lose it here.
Sophia,
She's not here in 10 minutes. Or
Teddy,
5 minutes more.
and Dylan, and Sabine, and Jay.
Yeah, I will.
Excellent. You would have had one last day.
Yeah, I know I lost it.
Okay, there are more.
Hello, O? We're not on O.
Are we on?
No. We're on N.
And for
It's a big
Where is the rest of N?
oh, it's so fun.
Where is the rest of N?
Did we get our quizzes great?
I would steal anything. Absolutely.
I don't think I have one.
Maybe we're out. Okay. I'm going to add to this. It says the conjugates of strong acids and strong bases. When we say strong bases, what do we mean? Pardon?
What was that? Fully
No, like, give me an example.
Um.
Just like, give me an example. The most famous example of all.
Oh wait.
OH. Well, the whole thing, though.
Oh.
That could just be an
NaOH.
NaOH. E, NaOH, strontium hydroxide, which is why the conjugates, which ions do not react, are metals +1 and +2, generally. So all +1 and +2 metals are not going to react in water because they carry hydroxides, and they're not going to go back and re-carry a hydroxide because it's a one-way reaction. Same, the conjugate bases of strong acids, HCl, HClO, HI, HBr, HNO3, those are all strong acids, so those conjugates are not going to accept a proton and make them again. They only go one way. This is an exception. It won't act as a base, but it will act as an acid. So you get that entire reaction.
Thank you.
Yes?
So how do you like have H2SO4 if the HSO4 can like immediately form like equilibrium?
You could ask that about any of them. How do you have HCl? How do you have HClO4? How do you have HI? Their answer is we don't make them through an acid-base process. So if you want to make HCl, you just bubble chlorine gas through water.
And how do you like contain them? Like just without water?
Acids and bases don't. Acids react with bases. Bases react with acids. You just contain them in something that's neither of those.
So just isolate it.
Yeah, in glass or plastic.
Would it usually be in like aqueous solution or?
They have to be in aqueous solution to have them as an acid. If you have HCl, for example, HCl, if it's not an aqueous solution, is a gas. So theoretically, you could have a tank full of HCl. It would then be called hydrogen chloride. It's not an acid yet because it hasn't hit water.
Oh, what would it
Once it hits water, dissociates 100%.
Okay.
Would it still be like, if you mix the base with the chlorine gas or the hydrogen chlorine gas?
Oh, it'll react with it because as soon as the chlorine gas hits the water, some of it will dissolve in, and that will.
What do you get, like two gases, like base
Two
gas
gas.
and acidic gas?
They would have to encounter each other. But it wouldn't be an acid-base reaction because that is, by definition, an aqueous reaction. They'd just be two acids reacting, I assume. I don't even know if they would properly react in that way. Yep,
I
Felix.
was wondering, this isn't on topic, but I was wondering when we get our quizzes back for Jake.
It would later.
Later? But wasn't it your goal to get
When
him
your
back?
when your hand is healed. I've been so depressed that your hand isn't
So
healed
finger.
yet. Finger. That I haven't been able to think of.
Okay.
Yeah.
But wasn't it your goal to
No,
do it
I
within a
know.
week?
No. Every time you talk now, you remind me of that.
What if he has an actual valid question though? Does it just like still remind you?
Felix, just no. I don't know why this page exists because it's the same one as the previous page. So I'm going to use it to come back and maybe put a question or two on. We're going to skip over to here, and we're going to do the alkali metals plus 1 and metals plus 3. This also restates what I want. So, this is just a reminder. I think I was probably falling off on this one. Conjugate bases of strong acids, number 1. 2, the alkali metals plus 1, the alkaline earth metals. I do have to be a little careful. I keep saying things like most and most of the time, and that's because there's solubility involved, and so there could be a low solubility something, and it wouldn't act as an acid, but it wouldn't give up all of its hydroxide either. So it's still not going to react in that kind of a way. So they're still neutral, and they're still spectator ions.
These are all the ones that are spectators?
Yep. Sure.
Can you give an example of like the exception you said?
No. I don't want to focus on the exceptions. Because right now I want you to learn the rules.
It's not gonna be on the test, right?
The exceptions? Not
Yeah.
really.
It's
Yeah.
gonna be
No,
on
no,
the
no, no, no,
test.
shh. Go to sleep. No dreams now.
How do you do that? Goes to answer
So we can regard the alkali metals and the alkaline earth metals as the conjugate acids of strong bases. Sodium hydroxide, calcium hydroxide. If they could re-pick up the hydroxide, then they would be acting, they would remove hydroxide from the system, and that would be sort of acting like an acid. Pardon?
The middle one.
CaOH2?
Okay. Oh, is there?
There we go.
So these don't react with water?
What? They don't react as, they don't pick up hydroxide. They don't go backwards. They- right? They still dissolve in water.
Okay.
And they're just to introduce the exception. So if you have aluminum hydroxide, Al plus 3, or say iron 3 hydroxide, they'll act as a base, but then they'll act as an acid. Hold it, I should check. Anybody still getting that down? Draw this.
Oh my god. That looks like a snowflake.
Kind of, yeah. For kind of similar reasons.
What did you write here?
I'm also going to draw it, but I needed a model to go by, so I put that one there. I'm going to draw a version of it here. So we have chromium plus 3, and I already wrote it wrong. So
Wait, do we have to draw that?
yep,
Oh,
no fun.
no.
Do you remember the grade 11, the hydration spheres that carried around ions? Like the jacket of ions around? It's the same thing, except at plus 3, the hydration sphere is so strong that you can guarantee there will be 6 waters surrounding that ion. And so in water, it's not chromium plus 3, it's chromium plus 3 bracket H2O bracket 6. There's 6 waters around all of them. So I need 6 waters. So that's going to be 1, 2, 3, 4, 5,
Oh,
6.
draw 2 of them?
Pardon?
We draw 2.
Yeah.
Okay.
But don't draw the next one completely.
Oh.
Because the second one is after something happens. And then what color did I make the hydrogens? Blue.
Why does it look like the structure of, like, I don't know, of glucose or something?
Probably because there's a lot of hydrogens and oxygens.
Yeah.
Yeah.
It looks like hexagon.
Well, and water has a particular Mickey Mouse ears bent shape. Which end of a water molecule is negative?
The oxygen.
The oxygen. So we have this really large plus 3 gigantic charge, and that's attracting the water molecules. What's the name of the attraction? Positive to negative? It has a dipole, so it has a positive and negative end. And dipoles attract each other through electro. You're close. It's got electro. in it. Electrostatic. Electrostatic's the word you're looking for.
I don't know, I'm speaking up words.
So there's an electrostatic attraction there. We've got our slightly negative end. We've got our slightly positive end here. And this is held quite tightly. So you've got 6 waters with chromium plus 3. The plus 3 is strong enough that this isn't one where they're jostling and going away and coming back. It's 6 waters. And they are there permanently in water solution. It's a bit like hydrates, which we learned in naming last year. Except those still exist in a crystallized form. And you can take them off and you get things like, what was it? Copper 3 sulfate hexahydrate. Except for this one only exists in water. If you dry this out, they're going to go away. But in water, it's got 6 hydrogens. And this pull is so strong because plus 1 and plus 2 metals have this hydration sphere as well. But now, this is a plus 3 charge. And so they experience a very strong pull. Strong enough that electrons leave hydrogen. A lot of positive charge attracting a lot of negative charge, and for one of them will be strong enough that the electrons will leave and abandon that hydrogen. And then we get a little OH. This is plus 3. This is minus 1. This entire thing is plus 2 now. And it's given off a hydrogen. And so in water, plus 3 metals will act as acids. They'll just attract the water hard enough that it abandons the hydrogen comes floating away. Now at this point, it's no longer a +3 charge attracting a bunch of ones. It can't do it again. It's overall only +2. The charge isn't as great because in addition to this +3, you now have this -1 repulsing everybody else. So it's not strong enough to do it twice, but it can do it once. Yes,
Wait, why does it lose the hydrogen?
because the +3 is so strong, so attractive,
Oh, I see.
that it's pulling it through.
Oh, it's pulled through.
Mm-hmm.
So is this CR3 plus that's so strong that pulls the H plus? Or
It's so strong it pulls the electrons out of that bond.
oh,
The electrons just slide on over to the oxygen because this oxygen is having its electrons here, lone pairs, being pulled towards the chromium.
oh.
That's it pulling electrons away, so it pulls more electrons from here, and then eventually that just pops off.
Will we hear draw this on a quiz or on test?
You could, yeah. If I said, why are +3 metals acidic? That would be very useful. However, if you needed to recreate it, you have a, oh, that's balloon. You have this in your table. Because the other way of writing this is like that.
What?
And that's in your table.
So that's like the.
That's this. So that's the equivalent. So you've got that. So this, Cr +3, H2O, 6, still +3. Notice it's not done as a hydrate. It's not a hydrate because it's not still there in the crystallized form. So it's an aqua. This is a hexaquachromium +3 ion.
When we screw
But
the
it lost an OH, but when we wrote it, it just lost the H though.
It did just lose an H in this as well because an OH is left behind. So the OH you're seeing is the one that's left behind. Yes.
how come this only pulls like one electron instead of two? Why is it like asymmetrical?
Why does it only pull from like one of them?
Yeah.
It doesn't have the it's not strong enough to pull from all of them. So it's just going to be a one of them, whichever one it happens, and through whatever motion, one ends up being slightly closer for a second. It's able to snap it closer, and then the hydrogen pops off. Once the hydrogen pops off, there's not enough positive charge left to keep going. That's just the stable state.
Wait, so it stays?
It stays like chromium, hexachromium, hexaquachromium. I'm not even sure I can name it.
Stuff on the right.
Yeah, so, yeah. Well, it's an equilibrium. It'll go back and forth.
What?
So this will pop off. It'll come to here.
Yeah.
Got a hydrogen. But also, if there's a pressure, like there's a lot of hydrogen around, it'll pop back on, go back there.
But you said you can't do it twice. Then
Or
what?
it can go backwards and then do
It can't do it twice in that you can't, I'll use a different color. It won't go like H2O5. It won't go like H2O4 and another one comes off, and H2O3 another one comes off. Like they don't just keep coming off. It only happens once.
So you,
But it can go back and forth.
So are you saying it's monochromatic?
Yeah, monoprotic. Ooh, that's a good way to put it. Over here.
How is it monochromatic when it has like 3?
Monoprotic means you give off one hydrogen
Oh,
only.
okay.
Yeah. That's another analogy. It's like the gossip about at Bonner Elementary. After the moms would drop off their kids at Bonner, they would get, what's the name of that nursery that's near here? Not with children, with plants.
Would we know that?
Yeah, can't remember. It's got a. I was just there getting some plants. Anyway, apparently the gossip was a bunch of moms would drop off the kids and then they'd go to the nursery because some young gardener had started there. They liked watching him lift things and carry it around, and the shift started about that time. So they'd go there, have coffee and gossip, and watch him.
What?
Thirsty moms. But then one of the moms divorced her husband, married the guy. Yeah. Or just, I don't know, carried on with him in some way. So got rid of one, boom. They still went and watched him, but he wasn't nearly as attractive. They couldn't do another one because he's already been taken.
Sorry, is this like this new gossip you told us, or is this like when your kids went on there? Like, is it like?
No, this is when Wilbur was at one.
Oh, okay.
Yeah.
Well, that's this is
Yeah.
not.
I don't
No,
know.
how you say young? What's this like creepy young or like?
It was a little creepy. He was like 21 or something, which is like children to these moms. Yeah. Yeah. Yeah.
That's gonna be me. That's gonna be me as a gardener.
If you ever want your ears completely burned off, just sit very quietly around a bunch of moms who don't know where that you're there. Okay, fill in the other ones, just to practice writing this.
They're literally the same thing, but with like a different.
Yeah, those are the three that are on your table. So pretty much all +3 ions will do this if they're soluble in water. There are three in your table.
Check the solubility.
Pardon?
You have to check the solubility.
There's three that are on your table. These are the three you have to know.
Okay.
But you have to know them because you have to be able to find them. The hardest part is just recognizing that they're here.
Yeah.
Because how many times did you glance through this and go, oh, this is actually Fe+3?
Yeah.
Probably not.
Didn't notice that.
And so you have to realize that these are the same thing. Cr+3 aqueous is actually equal to that.
Okay.
And there's also that one. So they're all there. Boom, 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 boom.
So the metals alone are equal to that whole
Yeah, in water, that's what they do.
hydro thing.
And they have a Ka. I mean, this one, iron. If you have iron in water +3, that is reasonably acidic.
Yeah.
It's 10 to the -3. So we're talking about moving over 1 to not 100, 1,000 products over reactants, which is decently up there. And there, I'll go back to here for anybody that was finishing those off. Good, finished in. I will come around and look at them while you're working on these problems. What I would like you to do is predict whether these three will be acidic, basic, or neutral. So write the expected hydrolysis. So another way of saying that is eliminate the spectator ion and write the hydrolysis, if any. Okay, and then say, will this be acidic, basic, or neutral? And
Do we do it on the board or no?
let's do it. Let's do it on the boards. Excellent. Taylor, you can join any group you like, or do it on your own.
Which ones? These ones or these ones? No, you go.
The other ones, I'm going to come around and look at the yeah, those ones.
I don't know. Get out of here. Get out of here. All this time. Hey, come here.
Eric, and then what you doing?
You play spot.
You can start calling you sodium.
Yes, call it sodium. Wait, and then you go back to the question.
Because he's always salty.
He's still salty. Alright. Give me the pen. Mr. Nico took all the pens up here.
Pardon? I just put them over there. They've always been over there.
Hey, throw one to me anyway.
Here, catch.
Well done. Like, see how it comes out.
Don't take the whole box. Just take a bed. You want to try? Just try the wood. Put it right there.
I think you have to eliminate the spectator on it.
Doom, doom, doom. No, 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 no.
Oh, is it with the?
Enough of these are getting right. As we do. Do you need any of them? There you go.
Can I get another one? This one's so kind of bad. Can I get a different one?
Yep, come on. Let's find one that's good. Ooh, that was good. How bad is it? Is that awful, or is it much more? That'll work. Don't throw it away.
Okay, yeah, we can say salt back.
So then
Let me
we'll-
like deep fry.
Do.
Oh, and then we mix the positive on.
1, 2, 3.
And then NH4 plus
That's good. So I think we have to write.
I would say,
Oh, I should do actual attendance. Does anybody know where Sophia is this morning?
I don't know where Sophia. I texted her. She didn't respond.
Well,
Is she not marked off?
but I don't know. I'm gonna go do that now. But she's probably been sick.
Wait, let me check. I'll see if she texted me. She still hasn't texted me.
You don't have to check. You shouldn't have your phone up.
Sorry.
I should take your phone.
No, but I'm helping you.
Okay, if there's a.
So that never happened. Okay. Wait, so it's acid or is? Oh yeah, it is acid. Okay, yeah. Okay, now Na and F. Go to Na plus.
Or sorry, ASAP.
Was it N? It's Na.
Okay, so weak acid, water is just like, is that base? Strong base. So which one do we want?
Okay. Sodium doesn't react with water. Is that what it is? So we have to do that one.
Wait, Eric, how do you get acidic? Because isn't NH3
Like,
you know,
they
like
graduated
most
in like 99.
basic thing you can have?
Yes.
You were teaching when my uncles were here. Do you remember? Yeah.
Was I? What year?
Well, one of them graduated, like, I think, like,
Plus, but then in this,
98, 97.
I started in '99.
But the other one graduated 2004.
Yeah, I would have been here.
Stefano.
Stefano.
Ruski.
Vaguely, actually. Yeah.
He was like he was a like a menace. And he was like very like out there.
He was a
Big
menace.
personality.
What do you say, Stefano? I may have heard his name in a few staff meetings.
Yeah, like recently?
No, back then.
Yeah.
That's the only way I knew him. I don't think
He was in Whittle.
Ooh, I might have taught him Science 10.
You definitely did. He
Yeah.
came in grade 10. And he's like,
Well, no, because I didn't teach Science 10 all the time.
he's in
I
the
did
Brightwood
often.
magazine too, if you saw him.
Pardon?
He's in the Brightwood magazine now. So that was like work or something. I don't know. I haven't seen it.
No.
That's so weird. I know, because I was talking to Miss Whittemar and she was like, I remember them very well. I was like, oh god.
Sir.
We have a weak acid and a weak base.
Yeah.
Do we do KBB reactions? Yeah, we have a strong.
What do you think you should do?
I think that. If I didn't have to do that, I would probably.
Oh, I think you should do what you think you should do.
Okay, so why is there salsa? That's what wrong.
let's do it.
It's so easy, it's not even fun. I like that.
Oh, what's water?
Yep.
Well, no, yeah, Mr. Johnson. I had my answer. He's like, how is Summer doing?
Okay, what do we got for the first one? We have that, excellent. Right, and you've got acidic. You've got acidic.
Oh, there's two
What?
equations. Oh, so it breaks down and then one equation is
The first one you need to look at,
But it's in here.
but I don't know what you did. The first one was.
Oh, is it
You've
missing
done
the
something on the
plus?
first one.
It's missing the plus sign.
You need to check your charges, yeah, absolutely. And then you need to say if it's acidic or basic, which you did, so that's good. And you've got number 2, excellent. And then number 3, you need to do something. Oh, how do you know that number 3 is neutral? If you think it's neutral, I want you to prove it.
But I have like two equations where one creates a zero plus and one creates a one.
Right? By the same amount.
I don't know.
You should have proved that.
Do they have this, is
Oh,
it proved by
S1
the
and Taylor, you need to say if they're acidic or basic next
Yeah,
time?
we're gonna do it after.
Okay.
H and O.
Acidic, basic, hold it,
Why is
that one, last
How
one,
is it?
needs work. It does. Also, with that one, why do you say it's acidic?
The first one?
No, the last one,
Because it created a
right? But I don't think you're quite done that. What you've written, nothing you've written is wrong, you're not quite done.
Oh,
It's not basic.
Yeah.
Okay, I think is it also basic?
Basic.
Oh, we gotta do NO2 minus.
Yo, Teddy, why is NO2 expected? How do you figure out the spectator
You
domain?
need to figure out the.
You just like find it on the table, see if it exists. If it doesn't exist, then it's gonna be a spectator.
So,
NH4 does exist on the table.
Yes, so it's not gonna be a spectator.
Oh yeah, that looks good.
Alright.
Okay,
And
so
H
it's the salt.
is
So
base.
the same
HBO is a K of 1. And then
So then is it? So now we gotta say that.
your first one still needs a little bit of work. Excellent, you've got 2 reactions, that's nice. Your charges need some checking. Now that needs more checking. H3O plus is good, because it is H3O
Eric,
plus.
isn't H?
However, how do you know it's neutral?
Ours is the exact same.
Yeah, but the same amount.
Well, we have here.
Hey, what's the difference?
So you would have to prove which one. accordingly. Yeah.
But they're not really
Right, so show your calculator. Oh, there you got calculator. So what is it, acidic or basic?
Mr. Newfeld?
Because those aren't labeled. I don't know which one's a KA and which one's a
Like these two
KD.
will cancel, right?
Mr. Newfeld.
Label what they are.
What am I missing?
No, these two will cancel, but
Your
then
charges
the next
are wrong.
piece, no?
No, it's something to do with probably like.
Yeah,
the
it does.
ACV.
That's true.
You know how they have.
NH3 is
Yeah.
not negative.
Concentrations and stuff.
Oh, it's neutral.
So I think probably
Get more?
Who's doing this one?
Alice.
Where'd you get 4.6 epsilon minus 4?
that's the KA on
Okay, we gotta figure out which one's stronger.
But HNO2 is not what's reacting. NO2 minus it.
Oh, we can find the K of the acid.
But
Oh, but you need.
that's a KA.
We need So
You've got
let's
that
do
one.
the KW equation thingy. So it's one
I don't know how to do the last one.
Who were you looking at?
equal.
Jay, why are you over there? You're not there.
Oh, so it's table.
And you have the whole last one to do. Also, if you write an acid, the H always goes first. HF.
Yo, what did you do next?
Okay, I just want that one.
I'm familiar with their equation.
I don't know
I'm
how
trying to
to
figure out how to decide whether or not
We
this
should
is
have
the first
like
or
two
second.
Right.
equations.
So, what value do you know that will tell you how strong an acid or a base is?
NH. Oh, I see.
Those
NH3.
two also reacts.
Yeah.
They react
However,
with the
one of
base.
those is an acidic equation.
Basic.
One of them is basic.
Yeah.
If they were identical, but
Oh.
they're not identical.
Oh wait, I see NH4.
We should find the
We
KB.
need the base. We need the base 5 plus 6 7 7.
There you go.
Acidic equation for NH4.
Yeah, because I need to find the KB.
Yeah.
So if
KB
that's
for
KW,
NO2.
And I think now everybody has this.
And then H10. Okay. Then we take the KW, which is.
We
What is that?
need 1.0,
do that.
so
Oh, okay. But we need the KB, right?
times 10 to the negative 14
then what's the
So
divided
this
by
is the KB, this is
4.6 times 10 to the negative 14.
Then this is gonna be north of there.
what's the other one?
It'll equal
Hmm.
Oh, yes, like,
times 10 to the negative 9.
Now we need to find the KB.
We find the KB of.
92?
So,
Okay.
And then KA
We need the
is
KW, which is. Wait, what's the KW again? It's 1.0. Right.
5.6 times 7 to the 10, so it's more acidic.
Equals 5.6 times 10 to the negative 1.
Yeah, 7 plus 10 to the negative 1.
So
I think that's right, yeah.
And now what did you do?
Wait.
You get the KB of the first one?
no, did it get the K?
Yeah, show me the top of the sheet.
Because there's two of those.
So is the last one acidic or basic?
We're finding that out.
Excellent.
It's acidic.
Why is it acidic?
There's more acid.
What's the number for the acid?
Well, the K is bigger than the KB.
Yeah, what is the Ka for?
5.6 times 10 to the negative
10 to the negative 10?
10. Yeah.
Did I write that down wrong? Oh, did I? I wrote negative 11, but
That's the other one.
no one's confirming me. Did I write it down wrong?
It's 10 to the negative 10.
10 to the negative 10?
5.6.
Times 10 to the minus 10. There we go. So yeah, then it would be acidic.
So is it really rare to get like exactly neutral?
This is acidic in that it probably would come out to like 6.5. So not really acidic. Like lemons is down to 4. So not hugely acidic, but yeah, it'd be a little acidic. It would be rare to get something that was, dead on. But as long as you have them, I mean, this is within an order of magnitude. They're both times 10 to the minus 10. So it'll actually, no, sorry, it won't be 6.8. Oh, they'll balance each other out. Oh, yeah, it might actually come out to be near neutral. So they're within an order of magnitude, so they're not going to be
How do you
huge amounts of
Yeah,
difference.
HNO2.
How did you spawn in like
plus
2 extra
OH
hydrogens?
minus
Did I?
Yeah.
Or did I do that?
should be H3O plus.
Oh,
And H, yeah. Should be OH, no?
I know that this is the base. I even calculated a KB for it. Or did I? So if you have two of them, you compare their Ka and Kb, and then whichever one is more. If you needed a neutral solution, this actually wouldn't be a bad combination. Because those of you who wrote neutral, we used to teach us something a little like this to the grade 11s, and we would have them predict things. A little bit of hydrolysis in ages and ages ago. However, we didn't actually have them calculate Kas, and so they'd look and go, you know, you're producing both, and it would be about neutral, so it's not a bad guess. And it probably comes out to quite a bit close to neutral. If you want to find one that is true neutral, getting the exact number would be hard, but if you at least got 10 to the minus 10 and 10 to the minus 10 for both, that combination would probably work fairly well.
So on the test, if we got the same, within the same 10 to the whatever, then you'd consider it neutral?
Well, if you have the access to the exact numbers, then you can say, oh, this one is slightly more acidic.
How acidic is the public swimming pool?
Pardon?
How acidic is the public swimming pool?
Oh, I have no idea. They add chlorine to it. Water itself, if it sits out. Yeah.
Would it like produce like hydrochloric acid?
Well, how often have people peed in it? It's a public swimming pool. And you create all those chloroamines. Some of those are acidic. Have you ever you've gone into a swimming pool and you smell that chlorine? If you just add chlorine to a pool and you let it settle and mix and
It don't
nobody's been in the
smell,
pool,
it's just the
it
pee.
doesn't smell.
It's the pee.
Yeah. When the urine hits the pool water, it reacts with the chlorine and that creates the gas
The more
that
chlorine
causes it
gets,
to
the
smell.
more
Because
pee
the
is
chlorine
small.
tablets that I
Why can I smell when it comes out of the tap?
Oh, they will smell. But I mean, once they're dissolved,
Okay.
let everything
So I was
air
like,
out, go
it's
back.
like-
No, yeah. But have you ever gone to a public school and it was like, it just hits you like a huge amount of chlorine? You'll notice a lot of, I'm tempted to say of kids, but they have found that adults are far more likely to blame. They have higher volume and are also more likely to do it turns out. Kids are more likely to run to the bathroom because they've been told. In studies where they have attempted to determine how often people pee in the pool, it turns out adults are the ones you should blame the most. Kids
How
are
did they
great.
determine?
Okay, but like in the water here sometimes, like it smells chlorinated.
Yeah.
In the tap.
Check for sudden temperature change.
People pee in the tap?
In a tap, it's reacting with things along the side. So it's not always that someone has peed in it, but it's reacting with, say, the nickel or the iron. Yep. If you run water here, or like into a bathtub for a very long time, let's say about 20 years, like I have, it will very slowly turn green because the chlorine is reacting with the copper and then that deposits in your tub. That's also responsible for this because it has to react with something. In a pool that's lined with concrete, it's not going to do that, but it will react with the amines.
I have a question for like the equation. Why are we dividing the KW by 4.6 instead of 5.6?
Isn't
Wait. Oh wait, no, maybe I'm stupid. Wait, hold on.
no. It's probably a good question because you're probably not getting. So where's NO2 minus? Well, let's get rid of all of this junk. Dylan, where's NO2 minus?
NO2 minus is. Wait, I'm looking for it. I can't. Oh wait, wait, what? I can't find it.
There it is,
Okay, right there.
right there, right?
Oh, it's one on the outside.
So you have to. That's the one you're using
Wait, so that's what we have to use.
to calculate the KV.
Oh, I see. Okay.
What were you using?
5.6 times 10 to the negative 10. Because that's the one for us.
That's the one
NH4.
for NH4.
Yeah, NH4.
So there's the Ka for NH4 plus,
Yeah.
and then the Kb is the Kw over the Ka.
Oh,
So
I see.
that's why you need that one in there.
What is permeable?
So we were trying to find Ka limit?
Yeah.
Oh, I see.
Well, no, you're trying to find Ka for this one,
Oh, and K.
but this reaction was a base reaction. So to compare it, how much is it going to make? So
Oh, we wanted to see how much the base
Yeah, 'cause,
would make of acid compared to the actual
a
acid.
K value is products over reactants.
Yeah.
So when you have the K value, this tells you how much of this is going to make and how
Yeah.
much is that going to make. And the larger the value, the more of that. So this, as 10 to the minus 10, 5.6, is going to make a little bit more of the HCl plus than this one because it's 2.2 times 10 to the minus 11. So it's one order of magnitude smaller.
So basically, we're comparing 2.2 times 10 to the negative 11 to the 5.6, and seeing
Yeah.
which one's.
And
So
which one's
since
bigger?
2.2 is smaller, then
It makes
that's
less.
the basic one.
Yeah, and it makes less hydroxide than the other one makes acid.
So the first one's acidic.
Yeah.
Okay.
So if you have this in solution, the whole thing should be very slightly acidic.
Okay. Because the acidic outweighs the basic.
Yeah. And because pH is a measure of a logarithm and it's orders of magnitude, they're only different by one order of magnitude. This can only make a difference by one pH. So take 7, take it down to maybe 6. That's about it. Good? Anybody else? Write the expected hydrolysis for, again, those. And so this is a similar practice to the last one. Will it be acidic or basic? New groups. Go. James, you may join any group or do it on your own.
Okay. So basically, we have to do H2O.
I'm with you.
I am sorry about the quiz. If you come see me this afternoon and get extra help, that would also be a good time to pressure me to mark them.
James, I'm thinking.
Wait, extra
maybe
hard
it
time.
breaks down into.
I start at 2 o'clock.
Are we not having a quiz on PLOM?
Today?
No, but like ever.
But then.
Oh, you're going to hit a whole test on it
NO2.
When?
soon.
Eric.
PLO might just take us one day
Why?
because it's small.
We do like
Astronomy? If you want to do astronomy.
Oh,
you
I
can
understand.
say-
Yeah, it's like, I feel like I get more fun on a constant basis. I really
No.
Which page are we doing? This page?
It was the next page.
You want to talk about like Star Wars lore?
Dylan.
There is no Star Wars
Is there a
lore in
lab due
astronomy.
tomorrow?
Pardon?
It's not a spaceship tomorrow?
Yeah,
I'm running up with the lab.
come this afternoon.
Because I kind of forget what we
There you go.
Just start writing. So we're saying this is AL, NO,
AL is gonna turn into, so write one equation.
There's probably one with the AL too.
Well, actually, just double arrow, single arrow, AL 3 plus.
We have to have that earlier, we talked about like.
No, this is just breaking this off. And then plus NO2.
Is it H?
Does everybody have the equation?
Here we
Yeah,
have AL.
Okay.
3
What
plus
time is it? 9:10? I will be right back.
goes to AL2 plus.
No, it is. Other people are doing it. I know. It's
Yeah,
really
that's-
weird.
Yeah.
Okay, I think it's like
Until I have church, you're in charge.
AL 4. Is it 4 plus?
Classes. We're done.
No.
We're done.
Classes
I was sitting.
Session.
I will not miss it.
You're gonna regret that.
Why does theirs look so different?
Wow, this is
Oh
Let's
wait,
get
it's
out
like
of here.
hydros.
Okay, equals.
Yeah, because it's a plus 3.
Doesn't it? Did it break down into AL2?
What?
Wait, whoa.
Wasn't it?
Plus 6. Oh my god. It's AL.
Yeah, AL2 plus hydrogen.
5, and then it's like 2 plus there. And then we have plus H3AO. And I don't, there's a plus there.
Plus H.
Yeah.
AL2 plus 2.
Like that's
Plus 2.
Oh.
Plus H.
What is that? I think it's H3 plus. Don't ask me.
I think this is like the basic.
Shit, they're all copying us now. Oh, wait, it's on this page. It's on this page.
Like, what?
Bro, Nick, how do you do this? How do you do it?
Oh, I know.
Well, they're both able to react together. Because we know that
And then
it's water, that's going to change, it's going to give us HMI.
So do it. Oh, I don't know.
Yeah. Oh, yeah, you already know.
Go.
Yeah,
But you know that the aluminum plus 3,
So,
like when we learned that
Wait, when it bonds with
the
water.
basically just does this. And since they both react, they both
How can you write the disassociation first?
Hmm?
How can you like separate the ions first?
Oh, wait, that's on two separate.
Because I know that NO2
1.4 times
is like a polyatomic ion, and AL is just like mildly.
Wait, are you sure? And it's not like they did it?
That's what they're doing.
But they did it the other way. Like instead of making H, it's OH. Which is a plus 2 charge.
What? Yeah, we're just adding another step.
Yeah. Wait. Yeah, no, you're right. The KB is 2. Oh, no, KB. So if the KB was bigger, it would have been basically. Yeah. Okay. It's a civil. Yay. We're done. Let's go.
The other way, we just added another step. And then start.
we need to figure out the K and B. Sure. Let's go with D.
Plus,
K,
what is it?
K,
Yeah,
K.
over here, I'll do this.
Do you do K, K, B?
Why plus 3? So that balances out. Ah, I guess we have to. Oh, plus an H.
And
Okay.
this one
you got in shit last time.
But I didn't even go down in assembly, so I just lied.
Because
Mr. Nichols texting me. What's going on?
Why'd you add an H2? Wait.
He's like, Dylan, hey, and I'm like, hi.
Why did you get this?
What is he doing? Should I FaceTime him?
Yeah, Nick.
Wait, no, he's probably in a meeting.
He's on a
Wait,
call.
from that.
Mr. Nichols. Yes.
Oh,
I think
Nick.
he was having a beauty and salon the other day.
Nick,
Always
He's
in
getting
trouble.
How do you
Am I in trouble? Is he
Ale
saying?
H2O
I had to run back to
5OH?
the house and I'll be another 5 minutes or so. Student
Goes
tell the class to go on to the
the
next
reaction
problem after
we did
they're
with
done
the
the current
current
one. I should
Yeah,
be
but like
back by 5.
I was not
Okay,
listening
so,
during. Can you explain how you
why do
get
you
that?
put Dylan in
R.
Okay, so
Let
this
them-
guy just texted me.
Okay, next question.
Bitch, don't even.
I'm gonna take that for now.
You write shit down.
Who's getting expelled though?
I don't know. Actually, that's a great question. Student issue.
Guy is so negative.
And I
That he like takes one of the electrons that makes one of these bonds.
Yeah,
Well, like, just accept it.
I feel
It's
like
H.
So you just write like it takes a +3. You just write H2O.
Yeah, because it takes one.
Oh
Basically, it takes the electron
Okay.
from one of these H's,
There's H in
which
solutions.
releases, which means you now have.
But this is its own separate.
Oh, so that is the same as this.
Yeah.
But there's
Basically,
also water.
We need to react to this.
H2O.
Okay, okay, let's do this then.
Because one of the H's from the H2O's turns into O.
What are you thinking? Are you thinking acidic?
Done. Great, that's one solution.
Yeah. But then that's basic.
Okay.
Yeah. They're both one's acid, one's basic.
But that was a flat.
Suddenly I remember my shot.
But
I'm just wondering if we even need to do that.
Wait, no. Acid base. Calculate Kb and Ka.
Oh, that's the question?
Well, it's which one's more, like what's is it acidic or basic?
What the AL?
That's the question. And that's what you must consider.
yeah,
Okay, look, it's acidic. Boom. I'm so
Done.
smart.
Nice, we got K. I'm just by looking at
I'm
it.
assuming AL's gonna.
So
Dude.
Well, at least that's what I wrote in notes.
Oh, okay. Sure, get this one. Sodium doesn't react with water.
It's good.
Sorry, let me rephrase. So, if something is antiquated, do you know if it acts as whichever one it's stronger as?
Oh my god. Samples are new film. It scored 3,000.
who wants to do a 2v2 draft battle? Taylor.
Ah.
2v2 draft battle.
Yo, I got you.
You're having fun with friends, right?
When you say, are you in Roger?
Yeah. Because base is accepted.
Okay, well, we
Sure, it's fine.
And become accepted.
hold up.
Go get him in trouble.
Oh, why are you playing favorites now?
Oh, okay. No one.
Because the base is accepted as it.
No,
Wait, what's the charge on? Is that
What are you playing?
It's
Oh,
a
yeah.
Do you play?
I have Clash.
Yeah, oh, I
Wait,
guess
wait,
it's
wait.
good program.
No, I
Yeah, that's what they're saying. I'm
playing,
so I think since it's
oh,
a stronger base, it'll ask.
Township.
Oh, there's 50-50 can't play.
I have Clash Royale, but I don't know how to play this. Like, I don't know.
Oh, I never
I used to, and then I got really like
Oh,
into it.
about the for the show.
My best friend's only been like 100.
We already heard of it.
For how they just have to send it to
Yeah.
email and sign it. But like,
Yeah. I don't know.
Level
Okay,
2
well,
repeating
these are
takes
like
so
the-
much time.
Like, it's like she's got the most rapid farm I've ever seen in my life. So like, I think she's like one out of
She's
stuck.
That's so fun.
It takes so long.
so I think my RC
Also, that card that I got played is
I'm not gonna look this up.
can't be.
We don't have any cards or.
20% credit or something.
Boom.
Yo.
You really make that sign, Nick.
Okay, now we play.
You really make that sign. That was so like,
What
it was
sign?
so cute. I'll show you, let me show you the picture.
Two giraffes.
Snow. It's like the cutest that I've ever seen in my life. And there's butterflies all
Is
over
it Pete that you are?
What?
Isn't it fate that you were my date?
It is.
Spring
Oh.
formal Christmas, but like fate is French, so as a renown. But it also rhymes.
Birthday?
No.
Okay.
No, fate. Like it's like
Dude, no.
celebration.
I'm gonna play defense, bro.
That's fete. Fallen fete.
Yeah, bro. Playing defense by playing offense, so fun.
It was very cute, Nick.
Okay, what's what we're doing now? Oh
Maybe.
no. You see the far
Yeah,
over
that's
this
a
card.
roommate.
It's not camera. Oh.
Yeah.
That's good.
It's cute that Zach was
Bro,
filming too.
you can't be putting this many goblins down.
Wait, we're not gonna write the quiz now because he's gone.
We were never
We
writing
were
our
never
quiz,
meant to
though.
write it.
We were never running. I forgot the
Bro, you guys are.
What?
Fuck. This is good.
Bro,
I don't know who's getting expelled.
bro, how can we get to the tower?
Yo, where's
This.
Bro, we're about to get 3 crown
I
money.
swear there was one.
Yeah, we can get three grab.
I connect with
Yeah,
music.
Okay, let's on that.
What was
That's
that?
right.
Yeah, what's up?
Run it back.
What are we supposed to do?
Oh God, no.
Oh, I picked the wrong card.
You're gone.
I gave him my Meyer back. Now it's down.
Oh, it's fine. I'm doing golden.
Wait, disconnect. Cause mine are being weird now.
What do you download card?
And then press like the.
That seems like something you would like. Oh, I thought it was connected with the version.
Are we doing something?
Oh,
I
okay.
got bonus.
What are you about to do?
I actually don't know what Sylvia's doing. She hasn't responded to me.
She's not feeling good. She's like, what's that?
Because HBO4
Oh, man.
is active.
Oh, value.
HBO4.
Oh.
And the ram
Not
runner.
even the case.
Oh my god.
HBO4 is the
3 crown coming around.
Oh my god.
Here's another HBO4.
Oh, but
Oh,
this one's awesome.
satisfying.
It's like very low down.
Oh, I have no air.
I've got some.
Put those spear bones in there.
I tried to I couldn't.
Start on the next one.
Okay.
I
Start
told,
working
I
beside
told
it.
everyone that, but they
Let's
just
go. Hold it.
Oh, I just didn't know.
I only see KA and KB calculations on one of them. Two of them.
We got ours.
Why
Needs to
is it
be.
on that?
We had.
Oh, maybe that one doesn't have one.
Oh.
Who's working there? You need one? If you have a KA and KB calculation, that's good. And I'll work on the next one on the board.
I did the next one right.
Wait, give me
Yeah,
a phone.
on the board.
Want to see it?
For the last one, you could pick your own proofs. Find someone who'll do it on the board.
What is this?
I want to see it.
Wait, you gotta choose
I just went back, found a student who's trying to skip a presentation by claiming to be sick, and sent him to do his presentation in the last 15 minutes of class.
That's evil. What if he's really sick?
I'm not going to name him. He's in grade 10. That's what all grade 10s do.
Wait, he was skipping class.
He asked for a note and just conveniently didn't tell Ms. Toporowski that he had a presentation today. Yep.
If I look at the table and see that.
Well, you prove it with numbers. Are you talking about the next
How did
question?
you find out he had a presentation?
What is this supercharged that?
Yeah, that one. Yeah. You can prove it with numbers or just show a statement, but on the board. I want to see when everybody's done. Apologize for being away. Some things are really annoying.
We've been cooking up in our heads. KK, let's go.
You know what?
You were playing candy. Why were you playing games?
Why were you playing games?
Oh, we don't have field for
We could turn it.
Lucas, stop playing games.
I'm not.
Mind
Mind games.
Mind game?
It gets rid of the
I took Josh's iPad away yesterday.
Josh,
Just the Mojo?
No, Gil. And he was playing a game, and so I just started using up all his stuff, and I won.
You did it?
Yeah.
That's actually
What game was it?
It looked like Clash of Clans, but it wasn't. It had
Clash
like,
Royale.
Oh my
yeah.
god, you played Clash Royale for Josh Gill.
But I would like to claim that win.
Oh, I'd like to go.
So HPO 4. Mr. Gage is like actually good.
Yeah, it's in.
Where's the
How did that go?
HNO2?
Sorry, who did you use up all the stuff?
That's a crime. Wait, I got it's just a very weak answer.
Right, define used up all the stuff.
Do we have the regatta dog?
We said don't use up all my things, so I just slid everything in that I could buy.
Like, it doesn't look.
I don't actually know how it works.
And then he said if you have the same shit, you just like go to my room and work with her. Yeah, you're a decent student.
Wait. Yeah, like all of them just say I got through.
What's your job doing in house security? That's the useless job ever.
An A? Bite your tongue.
Why?
You swore.
House security is the most sacred trust on campus.
That's accurate.
You are preventing your house from being invaded by the worst band of thieves ever to be stolen. Do you know that some groups put a premium and an award on getting a full school uniform? They'll take your blazer right out of the window.
No,
Actually,
they're like,
don't put your laptop on your
Wait, tell us the story about how you chased them.
Who puts their laptop on the
Like, it's
window?
banned.
We had someone walk into our house, go from room to room,
Take
and
all the
steal
phones.
cell phones and video games. So it was a while ago. There was physical copies of video games laying around.
Wait,
Once
someone stole the covers on the rugby poles.
Wasn't there a story where you like chased people across the field when they in
they
a
were
van?
trying to get into the house. There were a bunch.
Got in
These
the
are,
van and chased them down.
and I chased them across the field, and they got in a VW van and made an escape.
That sounds like something out of a movie. What
Well, not fast. The thing is, if you're running and you're chasing like 8 teenagers, you don't really want to catch them because 8 teenagers could kick my butt. So
you're
but
trying to
I'm
intimidate
6'5" and look scary, so they're running. I'm running quite a bit slower.
Oh my god, it's awful.
No, but Eric has to enter open house
So if
video.
the teenagers are afraid of you, and you're afraid of the teenagers,
I'm not afraid of them. I just know I could get my butt kicked.
if you won't run close to them because you're afraid of getting hurt, that means you're probably afraid.
I don't actually want to take a risk. But I'm not
But make
afraid.
sure they don't come back.
Yeah, yeah,
I'm
That's
not
my ring.
scared.
yeah. I just want them to go.
Make sure my house has premium security, Teddy.
Oh wow, that looks really cool. When my glasses were on, it looked like it merged up.
Look, it's got a little ear.
Oh, so this one. Ahem. Felix. Felix. Eshwan. Eric. This question was in acidic or basic?
That's pretty good.
Good. I think I saw acidic around the room. Now, if you're doing this and you want to prove it, you get the Ka is times 10 to the minus 5. You can do this calculation and then just do this part. Your answer, the Kb, is, in the bounds of 10 to the minus 10. Clearly, the Ka is larger than the Kb. You don't have to worry about calculating that point, and you can just say acidic. Because at that level, who knows? Is everybody done this one?
It's too hard.
What?
What? It's easy.
This is easy. What's the spectator eye? Right. And
You only want to look at HPO4.
so we have HPO4 minus 2. What does that do in solution? Gets an H. So we have PO4 minus 3 plus H3O plus.
Oh, we went the other way.
Or it gives an
I meant like
Like H.
Sure. Because it does both.
Oh, yeah,
But
but
there's one that's
Then what do we do?
it'll act as a base because it's strong, or well, it's a weaker acid than it is a weak base, so it'll
Right.
act as a base. And
So for this one, you look up the Ka.
Oh, wait,
Which
actually, I
one?
was getting it off.
So HPO4 is 6.2 times 10 to the minus 8. But for this one, 6.2 times.
You're right about the H.
It's PO3 minus.
What's it called?
Focus. I know this question appears in your test because I've read this test 1,000 times, and you will. This 1 second is a key piece of information because I looked up here. The Ka should be for HPO4, and so I need to find HPO4 on the left. So HPO4, where is it? Here it is. That should be the Ka. I wrote it wrong on the board because I was getting ahead of myself. Now, what students are tempted to do is they'll check and use that Ka to calculate the Kb. This is not the right Ka to calculate the Kb.
Oh.
Why?
Is
Yes.
it because the HPO4 2- is acting as an acid instead of base?
Right. This here, it's an acid. It's only the Ka. To calculate the Kb, it's for that one. So you need to find it here. So you need to find it in 2 different places. Calculate that Kb and that Ka, then you're good. So this is why it's important. The part that's important is that you have to know to go to 2 different places. It's so easy just to find it once and use that same number for both. And I know that's a thing. It's just a common thing students do when I'm marking a test or quiz, and I just want to warn you so that it doesn't happen to you. And you'll say, I didn't do that because Mr. Neufeld warned me. I stayed safe. We are now done, basically, PLO-N. PLO-O might take us 1 day.
Then we're gonna have a unit.
It could take us 2 days. But,
Boom.
boom. You got PQR to finish off acids and bases. They also will not take long because you already know how to do titration. They'll be like that, and they'll be on redox. Pardon?
Like redox would be.
Redox is the last unit.
Why do you need redox?
Because redox is fun.
Yeah, but that's not like in the cover.
Sorry?
Redox one of the hardest units?
No, redox is in regular chem. When you're in Chem 11 AP, they cover it in grade 11 to make room for more AP stuff.
Do you want it?
Are you going? Wait.
My sports over here?
Sure, that's awesome. Yep.
I think
Yep.
there's something
Yep.
that.
Yep. Back door facing the field. I should be at that desk there.
No, I love tea, but there's like a.
Are we house security meeting?
House security meeting right now. I'm just gonna save up and go.
I don't know where I'm meeting my job boss.
I don't think I have. What block is this?
Oh yeah.
A?